Hi everyone. We will be solving LeetCode 392 is subsequence problem today, and it's an important concept in strings. So I want you all to listen it very carefully. So we are given two strings S and T, and we need to return true if S is a subsequence of T. So before jumping to the approach, let's see what exactly a subsequence is. A subsequence is nothing but a new string that can be derived from an original string by deleting some of its characters. Suppose we have a string A, B, C, D, E, F, and we choose to delete, say, B, D, and E. So we are left with A, C, and F. So this becomes a subsequence of our original string. Also, we must make sure that the relative positions are same. What I'm saying is, suppose we write something like FAC. So even though all of them are present in it, still it's not a subsequence because the relative positions are not same. I hope it's clear. So here F appears before A and C, but here F appears after A and C. So there's a contradiction. So a string to qualify it as a subsequence, the relative positions must also be same. So I hope the definition of subsequence is clear. I've also shown two sample test cases. Suppose S is this and T is this. So in string T, suppose if we deleted H, G and D, so we would get A, B, and C, which is our string S. So this is a subsequence. So true. Similarly, in second example, A matches, so fine. X doesn't match with any of the characters. X is not even present in T, so that's why we return false, because this can never be a subsequence. So I hope the question is clear. So now let's head over to the approach. So let's come to the approach. So this is our first sample case, and we know it's a subsequence, so we return true. So to solve this, we take two pointers. Pointers are nothing but variables. So let's name it I, and for T string, we take J pointer. Let me index them as well. 3, 4, 5. So what basically we will do is string matching, or rather character matching. So see, for to qualify this as a subsequence, every character should match in string T, and also the relative positions should be same. So we will one by one match ith characters and jth characters of string S and T respectively. So let me show you what I'm saying. So initially both the points to zero index, I and j. So first ith character is right now is A, jth character is A. So both are equal. That means uh, it means that at least we found A. So let's search for B now in the later part of the string T. So we go to the later part by increasing the J pointer. And since we have found A, that is the ith character, we also move I pointer and I now points to B. So I hope it's clear. So now ith character is B and jth character is H, which do not match. So we will, in this case, when the characters don't match, we would just move pointer J because here they didn't match. I know. But what if they matched in the later part of string T? So that's why we just move the J pointer in the hope that we may find the ith character, that is B, in the later half of the string T. So now I pointer points to J and J pointer points to, I pointer points to B and J pointer points to B. Now both are equal. That means we successfully found B as well. So we move the I pointer now. That means now we would search C in the string T, and J is also moved further. Now ith pointer points to C and j pointer points to G, which are different. So we just move j pointer in the hope that we may encounter the ith character, that is C, in the later section of the string. I hope this is clear. So now again, ith character is C, jth character is D. Again, they do not match still. That's why we move jth pointer and jth pointer reaches C. Now both match. So in case of when both the characters match, we both move both the pointers. So I pointer reaches here, and j is also reaches the end of the string. So in this case, both I and j pointers reach the end of the strings. So now what we can see that here we can see I reaches the end of this string. That means I becomes equal to s dot length, and this means that all the characters of string s matched with string t. That's why only now we move the j for array, sorry, I pointers forward. If they had not been matched with the characters in t, we would never move the I pointer forward. We only move I pointer forward when there is a character match in string s and string t. So if I pointer reaches string s length, that means all of the string S characters matched with string T's character. That's why only that's why we reach the end of the string S. So this is our condition that we would be using. So we would simply write at the end that if I reaches S dot length, that means all character matched. Thus S is a subsequence. So we return true in this case. If this condition doesn't hold good, otherwise false. So I hope the question and the approach both are clear. So let me write the code as well so I can explain it more clearly to you. So I've written the code of the subsequence function. So here we have two strings s and t. As told, we take two pointers I and j, initially pointing to zero index. Now we put this while loop, and inside we put these conditions. That is I is less than s dot length and j is less than t dot length. See, we are matching characters, right? And we can access characters only if they are within the range of the, the string. Suppose the string is ABC. Here indexing is 0, 1, 2. Suppose I I initially points to 0, right? Suppose at some point of time I reaches, let's say 4. So indexing what here is range is 0 to 2, right? So how we will access 4? Because only 3 characters are there. That means indexing is from 0 to 2. So that's why we put those checks uh, that we would do this process until and unless we would just stop this process if we exceed the strings, if the index value exceeds the string's length. Because if we try to access 4 character here, we would get array index out of bound exception, array index out of bounds, because we are trying to access something which is not even present in our string, array index of bound exception. So that's why we have written these two cases. So we in the if block we check whether both the characters are same, that is ith character and jth character. As discussed, we move both the pointers forward by one position. But if they differ, we just move the jth pointer. And as previously discussed, if I pointer reaches s dot length, that means all the characters in S matched with T. That's only why we kept moving forward. the I pointer, and it reached the end ultimately. So that's why if I pointer reaches s dot length, we return true, otherwise false. So yeah, this was the code of the problem, and I hope you like the approach. Coming to the time and space complexity, time complexity, see, suppose length is m and length of t string is n. So time complexity is maximum of m and n because see there this loop can break in two cases. Either the I pointer reaches s dot length or the j pointer reaches s dot length. So whatever be the case, you always consider the maximum value. So if I pointer reaches the length, so we do m steps because we covered a string whose length is m. And suppose if j pointer reached t dot length, that means we performed n operations since we traverse the entire t string. So we take the maximum because when talking about time complexity, we consider worst case time complexity. That's why maximum. And space complexity is big of one, constant space, since we didn't take any additional space. So yeah, this was the approach, and I hope you liked the approach and understood the code well. So yeah, this was this for this video, and thank you.